We grew a lot of potatoes in large grow bags this past year in order to explore different materials to grow in and sources of fertility to feed the plants. One large part of this trial focused on how the typical topsoil that we have on this site can be amended in different ways so that it can grow a better crop of vegetables. We filled 50 large grow bags with topsoil, selected 10 different ways to amend this topsoil, and planted 2 seed potatoes from the same early main crop potato variety in each bag. It was really interesting to watch the plants grow, and it did not take long for significant differences in the size and appearance of the plants to appear, with some of them doing very poorly and others growing very vigorously. And we let the trial run, resisting the urge to feed the plants that were obviously struggling, and the results were really interesting, with a huge range in the weight of the potatoes that we were able to harvest out of the bags of soil with different amendments in them. We have access to a lot of topsoil that had been left in a windrow after being cleared from the site during house construction, and we dug out and sieved a lot of this topsoil for this grow bag trial. I filled 5 of the grow bags with this topsoil without adding any additional fertility or amendments to serve as a baseline or control for the trial, and this was one of the 10 different amendment options. I wasn't expecting much from these potato plants, as I figured this topsoil wasn't very fertile, as it had been left and overgrown for many years, and we cut off and removed the vegetation, as well as a top layer of topsoil which would have contained a lot of the buildup of organic matter. And the growth of the potato plants in these bags was quite poor, with signs of nutrient deficiencies appearing on the leaves by the middle of July, and the plants in 4 of the bags started to decline after that. But one of the bags had plants that were much healthier and substantially bigger. I figured it was because this one bag had been placed on a gap in between 2 sheets of ground cover fabric, and the roots of the potato plants had been able to get through the holes in the bottom of the bag and into the soil below. We had spread a lot of fertility on the surface of the soil underneath this fabric in order to feed the squash plants that were sharing this space. And it seems that these plants had access to a lot more fertility and water in the soil below, whereas the plants in the other bags were confined to the limited volume of the grow bag itself. The other 4 bags produced an average of about 1 kilogram of small potatoes between the 2 plants, which is a really poor yield, but it shows how poor a crop can be without adding some form of amendment to the soil. But the plants of the 5th bag produced almost 4 times the weight of potatoes, which really shows how much more productive they can be with access to more nutrients, water, and space to grow into. In another 5 bags of this same topsoil, I mixed 100 grams of chicken manure pellets into the topsoil before the same seed potatoes were planted. This is a form of concentrated fertility that I've relied on quite a bit for use in the gardens over the years, and 100 grams would have added about 4.5 grams of nitrogen, plus phosphorus, potassium, calcium, and a range of other elements. Into another 5 bags of the same topsoil, I added 25 grams of a conventional soluble fertilizer before planting, and another 25 grams when the plants were growing well. This 50 grams of a much more concentrated fertility would have added 9 grams of nitrogen, or about twice as much as what would have been added with the chicken manure pellets, plus a lot more phosphorus and potassium, and this additional amount made quite a bit of a difference. By the middle of July, the leaves of the plants with a lot more fertility added in 2 stages were significantly darker green than the ones with a smaller amount of slower release fertility being added before planting. And there was a noticeable difference in the height of the plants at this stage, though both of these sets were substantially bigger than the plants that had to make do without any additional fertility. And these larger plants translated into a higher yield, with the plants fed with the chicken manure pellets producing between 3 and 4 kilograms of potatoes from each bag, and the conventional fertilizer boosted the yield by an additional 1 kilogram from each bag, which is significant. I would expect that if I had side-dressed the plants with more chicken manure pellets midway through the growing season, a similar kind of boost in yield could have occurred. I often use these chicken manure pellets in the gardens in addition to a fair amount of compost, but this is the first time I've used the pellets alone, and it's the first time that I've used this type of conventional soluble fertilizer. And they both made a significant difference to the yield, at least this year, which is really useful to see. But I suspect the limited soil organic matter in this topsoil will be gradually depleted with each season of adding either type of fertility, without also adding compost or some other form of carbon, which might end up reducing the harvests year on year. In another set of 5 bags of topsoil, I tried the opposite approach. adding 5 liters of municipal compost to each bag without any additional concentrated fertility. This would have been similar to adding about 40 millimeters of compost to the surface of the bag, but I mixed it into the soil instead, which would have produced a ratio of about 1 part compost to about 7 parts soil. This is a lot of organic matter, which would have contained a fair amount of nitrogen and other nutrients in it, and I was hoping that enough of this would be released to be able to feed the growing plants throughout the season. But this didn't happen, with the plants being quite small and the leaves becoming quite a bit paler, and these plants dying off earlier than a lot of the others. It seems that this municipal compost, which was probably made with a lot of woody material, was not very rich, or at least needed a lot longer to continue to decompose before it would be able to release substantial quantities of nitrogen and other nutrients for use by the plants. I had suspected that this would be an issue, but I was hoping for a much better harvest. But these bags produced substantially less than the plants that were fed directly, though still better than those growing in soil alone. One bag produced quite a bit more, which is interesting, and I don't really know why. But with the other 4 bags, the results were really disappointing, and I think keeping this compost on the surface of the soil would have been a much better option, at least for the first year. This was a valuable and very visually convincing demonstration of the need to be cautious of mixing this type of lower fertility municipal compost into the soil, something we have been doing in a few of the gardens that we manage. I also mixed in 2.5 liters of this compost into another 25 bags of topsoil as a base for another 5 different types of amendments, which in hindsight was probably not a good idea. I was thinking that this compost would help to feed the worms and other soil organisms, as well as improving the water and nutrient holding capacity of the soil, and that the amendments would provide the nutrients to feed the plants. And I think that all of this would have been better if the compost had been left on the top of the soil rather than being mixed in, or if compost that was richer or more mature with a lower carbon to nitrogen ratio had been used instead. To one set of 5 of these bags, I added half a liter of general purpose dry fertilizer that I mixed up based on a recipe from Steve Solomon to produce a complete organic fertilizer, or COF. And the seed meal that was in this amount of the mix would have added just over 10 grams of nitrogen to each bag, a bit more than what it would have been added with the soluble fertilizer, and the yields were quite comparable. But I wonder if the broader range of amendments included in the COF mix would have improved the quality of the potatoes we harvested, especially with the trace elements. With another set of 5 bags of soil and compost, I decided to give the potato plants a regular liquid feeding of a general purpose concentrated fertilizer that I buy in, which is reasonably high in potassium. With the 8 feedings spread over the growing period, this would have supplied the plants in each bag with about the same amount of nitrogen and a lot more potassium compared to the conventional fertilizer. The leaves of these plants seem slightly paler than some of the others, which I saw as indicating that more nitrogen in the mix might have helped these plants. And the height of the plants and the yield of the potatoes was smaller than the ones grown with either the COF or the conventional fertilizer. And I wonder if part of the reason for this was that I didn't start liquid feeding early enough in the season to help boost the growth of the young plants. With another 5 of these bags, I foliar fed the growing plants with a dilute mixture of the same concentrated fertilizer, and the leaves of the plants were definitely a paler green. I could have added something with no more nitrogen into the spray mixture, but decided to leave the trial as it was to see what would happen in the end. These plants produced a significantly smaller yield of potatoes, despite the extra work of regularly spraying the leaves, and I don't know if a different foliar feed mix or more frequent spraying would be needed to improve the output of these plants. Another set of 5 bags were regularly doused with an activated compost tea, made with a biologically rich compost, soaked in aerated water, and a bit of molasses and fish emulsion mixed in. I wanted to see how this regular addition of lots of biology plus a bit of nutrients would impact the growth, thinking that this biology might help to speed up the decomposition of the 2.5 liters of compost that had been mixed into the soil, and help the plant roots access the nutrients they need from the soil itself. These plants had pale leaves and even smaller growth compared to the other plants that had been given a stronger source of fertility, and the yield was quite poor. Except for one plant, which had significantly higher yields, and I suspect that the roots of this plant had found their way into the fertile soil below the ground cover fabric, or perhaps there was some other factor. This is the first time I've tried experimenting with activated compost teas like this, and I'm not sure how to improve things with this kind of approach. With another set of bags, I've mixed in 5 liters of biochar in with the 2.5 liters of compost in the same topsoil. This biochar had been soaked in a mix of concentrated fertility and seaweed solution before adding to the soil, and the plants had decent growth with slightly paler leaves and a reasonable yield. Using biochar like this is supposed to increase the nutrient holding capacity of the soil, as well as possibly the moisture retention, both of which are important with such a small volume of soil in each of these grow bags. The results from this initial cropping was reasonable, but I suspect this mix will improve with age, and the addition of more concentrated fertility or better compost with each additional crop will continue to improve the growing capacity of each bag, if the biochar actually does what I think it will. Allowing time for the soil biology to incorporate the compost or biochar into the soil is an important part of all of this, and these longer or slower processes I think are part of the benefit of filling another set of 5 bags with the soil from underneath our composting area. This soil would have started out fairly similar to the other topsoil used in these bags, but it has had successive active compost piles on top of it for quite a few years. And the worms and gravity would have brought a lot of organic matter and nutrients out of the decomposing plants above into the soil below, with lots of time for this to be fully incorporated. Digging out this significantly darker soil and filling the bags directly without any additional fertility or amendments provided the best results in this trial. The plants were significantly bigger with stronger growth of darker leaves, but these bigger plants needed more water and had to rely on the same limited volume of soil in the grow bags. As a result, these plants were more affected by the dry and hot conditions that we had a few times during the season, and I found it difficult to keep the soil adequately moist, and the plants started to wilt a few times. This would definitely have restricted the growth and productivity of these plants, but they still managed to produce a consistently higher yield of potatoes than any of the other mixes. Especially with one of the bags, which produced the heaviest crop in the entire trial, with 5.7 kilograms of potatoes out of the 2 plants in the 1 grow bag, which is an amazing crop. I don't really know why this one bag produced so much more, but I suspect yet again that the roots of these plants had made it into the fertilized soil below, which would have also given them a lot more access to soil moisture. Whatever it was, the weight of potatoes from this one bag sets a very high bar of the possible yields of these plants, which none of the other plants in the soil-based grow bags came even close to reaching. Overall, I think this was a really useful and interesting experiment, even though I was quite disappointed by the small harvest from so many of the bags. And I learned a lot about how not to use this low fertility compost, how poor the topsoil that we dug out really was, and the benefit of different types and amounts of concentrated fertility. Having side-by-side comparisons like this made it so much easier to see how the relative health and size of the different plants and the color of the leaves can be a really good indicator about how well the plants will produce, or how many potatoes I could expect to harvest. And as is often the case, it is the outlier or unusual results that seem so interesting that offer significant opportunities for learning. It makes sense that placing the bags directly on the soil to allow the roots of all the plants to make their way through the holes into the soil below would improve the yields overall, and the few bags with larger yields seem to confirm this. But this goes back to the purpose of this trial, which was to explore using different types of amendments to increase the potential harvest of vegetables that we can get from the topsoil that we have to work with, using potato plants and grow bags to explore this in a reasonably controlled situation. This trial was not really about finding the best ways to grow potatoes in bags like this. Placing the bags directly in the soil is probably the easiest way of improving the yields overall, but this adds another variable to the trial and likely obscures the differences between the amendment methods. I had decided to let the trial run as originally planned this year, without intervening when things were obviously not growing very well in some cases, to see what the results would be. And it was really interesting to see how poorly some of the plants grew and how productive other plants were. And looking at a few of the really high yields, I'm quite tempted to shift the focus of the trial next year, to try to get the best yield I can for each method or fertility approach, adjusting how compost is added and how much concentrated fertility is added and how frequently. This would also include using a dripper watering system to reduce the chance of the soil in the bags drying out, which will help all the plants and save me a lot of time in hand watering. And next year I might enable the roots from all of the bags to make their way into the soil below. I just hope there isn't too much variation in the soil fertility underneath to distort the results too much. But this might be worth the risk, especially if we can greatly increase the amount of potatoes we can harvest.